Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and this week I'm going to discuss how much ventilation air you need to bring into a space. So a couple weeks ago I discussed ventilation air, which is the fresh outside air that we bring into buildings for indoor air quality. So ASHRAE Standard 62.1, Ventilation for Acceptable Indoor Air Quality, not surprisingly tells you how to do exactly that, how to bring in fresh air for indoor air quality. So you bring in your outdoor air through louvers on the outside of the building. They look something like this. You'll see them in various locations on different buildings. Hopefully, because you want to have fresh air, they're not located near a source of contamination like the dumpsters or the loading dock. And ASHRAE 62.1 sets minimum distances from these things. For instance, ASHRAE 62.1 says you must be 15 feet from a chimney. So this would be 15 feet here. And that you need to be 25 feet from a truck loading dock. So we'll draw that over here. You can look at the standards, see all the other specifics about where you can and can't put your outside air intakes, but you get the picture. You want to locate it somewhere that you are actually getting fresh air. So what I really want to discuss on is the ventilation airflow volume. So we'll make a little room on this page. So how do you know how much fresh air you need to bring into a building? Well, that depends on how many people are in the zone and how big the zone is. Standard 62.1 has a table called Minimum Ventilation Rates in Breathing Zone. The table gives you the minimum airflow per person and per square foot of space for different types of spaces. And so it looks like this. You can see that a classroom for ages 5 to 8, you need 10 CFM per person and 0.12 CFM per square foot. So let's say we have 20 kids in a 30 by 30 classroom. You'd need 20 times 10 CFM per person plus 0.12 CFM per square foot times 30 by 30, the space size, and that equals 308 CFM of ventilation air in that space. So now what do you do if you don't know how many people are going to be in the space? The table also gives you default values that you can use. So over here you see the default value for occupant density is 25 people per 1,000 square foot, and then you can use that to calculate the airflow you need. So for that same classroom, we have 25 per 1,000 square feet times 900 square feet. And then you multiply that by 15 CFM per person, and you get 338 CFM of ventilation air that you need to bring into the space. So over here we have the equation if you know how many people are in the space, and down here is using the default values. So let me move this over a little bit because I want to discuss one more section, zone air distribution effectiveness. So different air distribution methods have different ventilation effectiveness. Zone air distribution effectiveness is the measure of the effectiveness of the supply air distribution system to get the ventilation air into the breathing zone. It's basically, does your fresh air get down to where the occupants are? So in the standard, there's a table that has different types of air distribution systems and what their ventilation effectiveness is. For example, overhead cooling, your standard ceiling supply diffusers, has a ventilation effectiveness, E sub Z, of 1.0. On the other hand, overhead heating depends on a couple things. So again, another diffuser, this time we're in heating. So if your temperature differential from the supply air to the room temperature, delta T, is less than 15 degrees, so say 90 degree air in a 75 degree space, then your E sub Z is 1.0. Your ventilation effectiveness is the same as overhead cooling. But if your delta T is greater than 15 degrees, then your E sub Z drops to 0.8, meaning that you have to bring in more ventilation air if your supply air temperature during heating is warmer than 15 degrees over the space temperature. And all of this is important because during heating, the more cold outside air you're bringing in, the more energy you have to use to warm it up before you supply it to the space. And one more thing on that, if you're less than 15 degree delta T, you also have to get the 150 feet per minute throw, T150, to 4.5 feet above the floor to keep your 1.0 ventilation effectiveness. So let's look at one more system type. For displacement ventilation, it actually has a ventilation effectiveness of 1.2, meaning that you can reduce your ventilation error if you use displacement ventilation systems. Okay, let's bring all this back on the screen. So there's obviously a lot more detail in ASHRAE 62.1, but that's the basic calculation for finding out how much ventilation air you need to bring into a space. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.